This is my second video lesson for Unit 14. In this lesson, we'll be analyzing redox reactions. Go to page 7 in the class packet. Learning target. At the end of the lesson, I'll be able to identify which element is oxidized and reduced in a redox reaction. Homework is number 2, which is a junior pod based off this lesson. Oxidation is when an atom loses electrons. Reduction is when an atom gains electrons. Typically, a metal is oxidized and a nonmetal is reduced. Predict the charge of an element after oxidation and reduction. When an atom loses electrons, it becomes more positive, so the charge or oxidation number becomes more positive. When an atom gains electrons, it becomes more negative. The charge or oxidation number becomes more negative. Here are some catchphrases to help you memorize oxidation and reduction. The first one is oil rig. Oxidation is lose, reduction is gain. Leo Ger, losing electrons, oxidation, gaining electrons, reduction. Learning check number 1, during which process does an atom gain 1 or more electrons? Pause the video and resume as completed. The answer is choice 2, reduction. Learning check number 2, which change in oxidation number indicates oxidation? Pause the video and resume as completed. Oxidation is the process of losing electrons. If you lose electrons, you become more positive. So the answer is choice 1. Learning check number 3. What occurs when chromium 3+ ions are reduced to chromium 2+ ions? Pause the video and resume as completed. The charge or the oxidation number of chromium decreases or is reduced from 3+ to 2+. Reduce means to gain electrons. So the answer is choice 4. What is an agent in terms of science? An agent does a particular role. It causes something to react. So what do you think oxidizing agent do? It causes a substance to be oxidized. So is the oxidizing agent losing or gaining electron? Since oxidize means to lose electron, the agent that's causing the substance to be oxidized will gain electrons. So oxidizing agent causes a substance to be oxidized. The agent itself is reduced. A reducing agent causes a substance to be reduced, but the agent itself is oxidized. So here's a diagram to illustrate this. Let's look at an example. Here we have sodium plus chlorine to give a sodium ion and chloride ion. Let's look at the oxidation numbers. This sodium has an oxidation number of 0. It goes from 0 to positive 1. Therefore, sodium was oxidized. Chlorine goes from 0 to negative 1. Therefore, it is reduced. Sodium is the reducing agent, and chlorine is the oxidizing agent in this reaction. Now let's analyze oxidation and reduction using a number line. From left to right is oxidation. As you're losing electrons, your oxidation number becomes more positive. From right to left, it is reduction. You're gaining electrons. The oxidation numbers become more negative. In this practice, use the number line to figure out if it's oxidation or reduction and how many electrons are gained or lost. Pause the video and resume once completed. Here are the answers. An oxidation-reduction-redox reaction involves a transfer of electrons. It must follow the law of conservation of mass, energy, and charge. In a redox reaction, the number of electrons lost is equal to the number of electrons gained. In this redox reaction, carbon is being oxidized. It goes from an oxidation number of -4 to +4. It lost 8 electrons. Oxygen is being reduced in this reaction. There are 4 oxygen atoms. Each one gains 2 electrons. The oxidation number goes from 0 to -2, so a total of 8 electrons gained. This is the reducing agent, and this is the oxidizing agent in this redox reaction. All single replacement reactions are redox reactions. All double replacement reactions are not redox reactions. Later on in the lesson, we will look at examples to prove this. To check if a chemical reaction is a redox reaction, you must check the oxidation number of each element in the chemical equation. If the oxidation numbers change from reactants to products, then it is a redox reaction. However, if they stay the same, then it's not a redox reaction. Let's look at this example. The oxidation number of this iron is 0. Oxygen is also 0. On the product side, the iron is positive 3 and the oxygen is negative 2. Iron is oxidized in this reaction and oxygen is reduced. Since there's a transfer of electrons, this is a redox reaction. Learning check number 4. In a redox reaction, there's a conservation of what? Pause the video and resume is completed. The answer is choice 3, both mass and charge. Learning check number 5. In a redox reaction, how does the total number of electrons lost by oxidized substance compare to the total number of electrons gained by the reduced substance? Pause the video and resume is completed. The answer is choice 2. The number lost is always equal to the number gained. Now let's look at different types of chemical reactions and identify if it's a redox reaction or not. What type of reaction is this? This is a synthesis reaction. We're now going to identify the oxidation number of each element. So why is iron oxidized and chlorine is reduced? Iron goes from positive 2 to positive 3. It becomes more positive. Chlorine goes from 0 to negative 1. It becomes more negative. It gained electrons. Is this a redox reaction? The answer is yes, because there's a transfer of electrons. Both oxidation and reduction is occurring in this chemical reaction. For question 2, we have a double replacement reaction. From the previous slide, we know double replacement reactions are not redox reaction. Let's prove it. Let's first record the oxidation number of each element. As you can see, there is no oxidation or reduction occurring in this reaction because the oxidation number of each element is not changing when it goes from reactants to products. All the hydrogens are positive 1, and all the oxygens are negative 2, all the sodiums are positive 1, and all the chlorines are negative 1. So this is not a redox reaction because there is no transfer of electrons, there's no reduction, and there's no oxidation that's happening. For example number 3, we're looking at a single replacement reaction. If you recall from the previous slides, all single replacement reactions are considered redox reactions. Let's prove it. Let's record the oxidation number of each element. As you can see, magnesium is oxidized in this reaction. It goes from 0 to positive 2, and hydrogen is reduced. It goes from positive 1 to 0. So this is a redox reaction because both reduction and oxidation are occurring in this reaction. There is a transfer of electrons. Learning check number 6. Given the reaction, the oxidation number of zinc increases because it's what? Pause the video and resume is completed. If the oxidation number is increasing, it's becoming more positive. Therefore, it lost electrons. Answer is choice 1. Learning check number 7. What occurs during the reaction below? Pause the video and resume is completed. Let's look at the oxidation number of manganese. On the reactant side, manganese has an oxidation number of positive 4. On the product side, it has an oxidation number of positive 2. Since it goes from positive 4 to positive 2, manganese is reduced in this redox reaction. So the answer is choice 1. Learning check number 8. Given the redox reaction, which species serves as the reducing agent? Pause the video and resume is completed. The reducing agent itself is oxidized. If we look at the redox reaction, chromium goes from 0 to positive 3. It is oxidized, so the answer is choice 1. Learning check number 9. In the reaction, hydrogen is what? Pause the video and resume is completed. Let's identify the oxidation number of each hydrogen. This one is positive 1. This one is also positive 1. And this one is positive 1 as well. Since there's no change in the oxidation number of hydrogen, it is neither oxidized nor reduced. So the answer is choice 4. In this table, you're given chemical reactions. Identify if it's a redox reaction or not. If it is a redox reaction, identify which element is oxidized, reduced, oxidizing agent, and reducing agent. Try to do this yourself. Pause the video and resume as completed. Here are the answers. This concludes the video lesson. Remember to do the Juniper homework.